A very warm welcome to you once again. Thank you for joining. This is Dr. Zulfikar Kassam. We're going to work on the Cisco packet tracer today. We'll continue on from where we left off last time. So last time we had built this network with 4 computers, 2 switches, 1 router. We had configured the computers, we configured the router so the packets could go around the network. Today we're going to learn a little bit about troubleshooting skills that you can use in your work and using the Cisco packet tracer as a means to learn those commands. And I'll also be introducing a web server to this network, which can be useful, and we'll do some troubleshooting there as well. Okay, so stay tuned till the end. Hopefully you can take advantage of that. All right, so let's start where we left off from last time. We had computer A in here. If we look at the configuration of computer A, this was basically using the default gateway, which was the Cisco router on this side. 192.168.1.254 is the interface of the Cisco router on this side. And over here, the interface is 192.168.2.254. Okay. So this computer uses this part of the Cisco router as the default gateway. Its own IP address is 192.168.1.1 was computer A. Okay. And then computer B, if we look at the configuration there, computer B, the default gateway is same. The same Cisco router is being used by computer B as a default gateway. And then we have the fast Ethernet, which is its own interface at 192.168.1.2. So this is the second computer network. If we look at computer C, we have the configuration as using the other portion of the default gateway on the other side of the router, 192.168.2.254, right? And its own IP is 192.168.2.1. The computer C has this address here. And if we look at computer D, on this side in here, we have the configuration as being using the same default gateway on this side here, 192.168.2.254. And the fast Ethernet interface is 192.168.2.2. Okay, so we have that in place already. So what we're going to do is we can see all green arrows after we start the Cisco packet tracer. If you want to see the whole lab, please refer to the previous labs in which we did the whole setup of this network. Okay. So just FYI, lecture 12 is where we built this network. Lecture 13 is where we looked at simulation, whereby we could see how the packets flow through the network. Okay. So for today, we are right now on lecture 15. Whereby, as I mentioned, we're going to do some troubleshooting here, just troubleshooting skills. There's nothing wrong with the network right now, but we'll do troubleshooting skills so you have better visibility of the network, and we'll introduce a web server as well. Okay, so what we're going to do here is we're going to go to computer A here. We'll go on the desktop here, and we'll run a command here. So the command we're going to run here is arp-a. This shows that the ARP table is supposed to be a mapping of IP addresses to the MAC address. So layer 3 address, which is IP address, to the layer 2 address, which is a MAC address. Okay. So right now, as you can see, we just started this network, so everything is empty. The ARP table is empty. Now we're going to ping 192.168.2.1. So we're going to ping computer C. Okay. So you notice the first one times out because right now this is the first time using it, so that's fairly normal to see one ping miss. That's the first one. Okay. So don't worry about that too much. If we do a second ping, now all the replies come 100% through. So you may find that the first ping actually misses, but don't worry about it too much. So now that we have pinged the 192.168.2.1 address, now we notice from the lecture number 13 that the for this to happen, there must have been an ARP request sent to figure out in this, our case is going to be the router, right? Because as far as layer 2 is concerned, layer 2 never traverses the router. So any layer 2 information, which is the MAC address, never traverses the router. So basically, computer A will never know the MAC address of computer C or D, right? Because it's on the other side of the network, right? So now if we do ARP minus A, we see something in here. We see actually the IP address of the router, because as I mentioned, these computers, to be able to send information to the other side of the network, need to forward this information to the default gateway. So the only IP address and the only MAC address that is important to them is the default gateway IP address and its corresponding MAC address, right? Isn't that fascinating? However, you won't see anything on the other side. And if I now ping, okay, I'm going to go back and ping the computer D. So I'm going to ping computer D, should be similar response, meaning to say the first ping will be a miss, and then subsequent pings will work, and I can do another ping in here as well. So you can see I am able to ping computer D, but if I go once again to my ARP cache, there should be only one entry, because as far as computer A is concerned, it just needs enough information to forward the packet to the router. Then the router will take care of the rest. Okay. Now that we have done this, now let's do, on the other hand, a ping to a computer in its own network, which is 1.2, which is computer B. Okay. If we ping here, we're getting a reply right away, because now this is on the same side of the network, so it responds right away. 1.2 responds right away. And now if we look at the ARP table, we can see it has information, once again, only of computers on its own network, which is computer B, and the router on the left-hand side of the network, right? So now it has learned the MAC addresses, right? So it has saved this information in its ARP table. So in the future, while the information is in the ARP table, it does not need any more to send an ARP request. It right away will read its own ARP table and make a decision where the packet is destined for. Okay, so that's one interesting troubleshooting tool that you can use to look at the ARP table and see which addresses, which IP addresses, and what is the corresponding MAC address for all the machines you have been interacting with. Question is, when and why does this become important? It does become important if you see some addresses that you have not been interacting with, and you see this ARP table full of kind of weird addresses, chances are you are being attacked. Okay, so for security reasons, you may want to keep an eye on the ARP table. If you see something strange happening to your network, if you see your network is completely slowing down and things are not working, look at the ARP table. See if it has learned addresses that do not exist, or somebody has plugged in something into your network that you did not anticipate to see. The other place to look at the ARP table, of course, is the router itself. The router will be having its own route table. So now let's go onto the command line interface on the router itself, right? So we'll go enable here. Okay, now for the router, we can say show ARP. So you can see the router has learned quite a few entries, or quite a few ARP entries in here, because now it needs to understand that, hey, this is computer A, so I need to know its MAC address, computer A's MAC address. It needs to know its own MAC address, 1.254, and 2.254 is its own address on the other side. So it has learned that. It knows which interface this is sitting on, which is great, right? The gigabit 00 is this one. The gigabit 01 is on the other side. So it has learned both the MAC addresses. It has also learned the MAC addresses of computer C and computer D, right? So this is a great place to look as well. Another reason why we want to look at the ARP table, once again, let me reiterate that I have come across a situation in a company whereby somebody had introduced a rogue computer into the network, And this computer was scanning all the machines in its own network and filled up the ARP table. So the ARP table was full of erroneous entries. So are entries that should not exist because this machine was trying to attack and bring down the whole network. And if your ARP table is filled, your computer or your whole network will come to a standstill, right? So if you're troubleshooting uh, a weird situation in which your computer is or your whole network is down to a standstill, look at the ARP table of this router, okay, to make sure everything looks good. If you see erroneous entries here, somebody has basically um, broken into your network and looking at things or trying to flood this ARP table. Okay, this is ARP flooding. Okay, so that's something you probably don't want to see, obviously. So this is one great place to look. Now, what we can also do is look at the switch as well. Okay, so we'll enable in here. Now here, the interesting one is the switch is not aware of the IP IP information. So it does not know layer 3 information. The switch is a layer 2 device. So it will understand MAC addresses. So the thing you want to look at the switch is the MAC address table, right? So if you go show MAC address table, you can see it has learned MAC addresses in here. Once again, because layer 2 information does not traverse to a different network, it will only learn the MAC address is on its own switch. It will not be able to find out what's happening on the other side of the network, right? So you can see it has learned the MAC address of computer A over here, right? Computer B, which is fast Ethernet 02, and it has learned the MAC address of the router. So these are great troubleshooting tools to understand what's going on in the network. Right. So now what we're going to do is we are going to introduce a web server to the network. Okay, so what we can do here is we can click on the end devices in here, and we're gonna drag a server on this side of the network. Okay, so we're gonna connect a server to the network. So we're gonna use a straight through cable to connect this server fast Ethernet port to the switch. So we can use the next available port, or we can go with the last port. So to make it easier, let's go with the last port available, fast Ethernet 024. Okay. Now we remember that this computer here has an IP address 192.168.2.2. Okay. So to be able to be on the same network, we have to understand that the network address, which is 192.168.2, which is the network address, has to be the same. The last octet, which is the host address, needs to be different. Right? So 192.168.2, so something in this range. So we're going to go to the server. You can see it's green right now, so connectivity is there. We're going to go configure this interface. So we're going to go with IP version 4 address. We'll learn about IP version 6 later. 192.168.2. Let's call it 100. Okay. So we have configured this, and what we do need to do is also configure the default gateway, right? Otherwise, it won't be able to communicate to the other side of the network. So 192.168.2.254. Okay. So now we have configured this. We'll just go to the desktop, make sure this is good. So let's go to the server. Let's go IP config here to make sure. So we have its IP address .100, and the subnet mask is 255.255.255.0. So the significant part is here, which is the network, and this is the host address. The default gateway is the IP address of the router. So let's see if we can ping the router from, so this is a good troubleshooting skill as well. Ping the router 192.168.2.254. If you cannot reach other parts of the network, just make sure you're able to get to the default gateway, which is the IP address that we are trying to ping, right? So we can get to the router from the server, right? So server can ping to the router here. So the server can reach the router, which is great. It should be able to ping other machines on its own network. So 192.168.2.1, which is computer C, that should be working fine. And then computer D should be working fine. You can see a reply there. Let's go and try and ping computer A, which is 1.1. So you can see a reply there. And we can go to computer B as well. Okay. So, alrighty. So we can basically ping all the machines on the network from the server. We can ping the router, obviously, because that's there. We did see that. The router is able to forward this information. Okay. Now, another useful command to also run on the router, we saw the ARP command, the show ARP that we just did just a moment ago. We can also look at the routing table. If you look at the routing table, you can go show IP route. Okay. So this will give you the routing table. Okay, so what this does here, you can see here, show IP route, right? These are the different designations. If an interface is local, it should be an L. If it is connected, it will be a C. If it's a static route, it will be an S. If it is configured by RIP, which is what we did, we used the RIP to configure the routing within this particular device, right? So if you go to config here, just as a quick reminder, if we go to RIP in here, we specified the two networks that RIP is going to be used for, okay? So coming back to the command line interface, we can see that this router realizes that 192.168.1 network, which is on this side, on this leg, is directly connected using gigabit Ethernet 00. And then the router itself knows its IP address, which is directly connected using gigabit Ethernet 00. It also realizes that, hey, the other side of the network, which is 192.168.2, which is on the other side, is directly connected to 01 interface, right? And it realizes its own IP address, and that's when it says /32. This is the network address. /24, this is its own address, right? So this is what the routing table looks like. So always good to go on a router and look at its routing table if things are not quite working, to understand why that is the case, right? So that's a useful command to understand. Okay, so now let's go back to the server. We had introduced the web server. Now, if we look at the web server that we would like it to be a web server, let's look at the configuration and the settings in here. So we have configured the default gateway, so everything looks good here. But now let's look at the services we can configure on this machine. Okay, there's HTTP, which is web services. There's DHCP. We'll look at DHCP in the future. And we can configure other entries in here, which is DNS and so on and so forth. So there's quite a few services we can configure. For now, we'll focus on HTTP, the first one, and we can see HTTP here. So by default, this is actually on. HTTP and HTTPS both are on by default, right? You can see that this web server is hosting a few pages, right? And as I mentioned before, HTTP is not very secure. We're going to shut that down shortly, but we need to do some exercise before that to illustrate some purposes. Okay, so let's look at if we can get to any of these pages like hello world.html. Okay. So now we'll hop onto one of the computers here. All right, so we have gone to computer number A here. And if we look at the desktop, we have different options here. So we're going to click on the web browser. Okay, we're going to do here is http:// the IP address of the web server / world.html. Press enter. Here, we can reach the web server. Okay, so this URL tells us that we can reach the web server from computer A. I can do an HTTPS over here as well, and I can reach hello world as well. You can try other pages in here. If you go back in here, we notice in the services, we have image.html, for example. You can try that. So here we can try image.html. Okay, so this brings us to this page, right? So now we can see we have set up a web server here, and we can connect to it using HTTP and HTTPS as well. So we go back here, we type in HTTP, everything is working. Now we're going to go to the server and we'll shut down the HTTP because this is not very secure. I'm going to turn off this service in here. Okay, I'm going to turn off this service in here. Now we're going to go to computer A back again. You can try this from different computers as well, no problems. Should all be working. So now we're going to try HTTP once again. Now that, so let's change this so that, because this is static right now, so to go HTTPS, it works. And how about we try HTTP? It shouldn't be working, so it doesn't go anywhere. So let me server reset connection. You can see that the server has reset the connection when we try using HTTP now, because now that's shut down. Okay. One thing you can do also, which is interesting as well, and on the command prompt, we can see if we can telnet from computer A to the server. So telnet to 192.168.2.100 on port 80. Port 80 is HTTP. So now we realize we have actually shut down that port. So this is not going to work. It says connection refused by the remote host. So this is port 80. So what you're trying to say is, hey, connect to the server on port 80 and the connection was refused. If we try this on 443, which is actually open HTTPS, you can see it is actually trying to open that connection. Okay, so it's not being refused. Okay, so this tells us that port 80 is not open on the server, but port 443 is actually open. It's trying there, and you can see the connection is now open. So you can use Telnet to figure out if any port on any specific server is open or not. So that's a great troubleshooting tool. Thank you for watching today. Have a great day and hope to see you again. Take care. Thanks. Bye-bye.